Welcome back. In this lesson, we're going to look at the resources in the air. So the gas resources that we would have, keeping the air clean, and how important that would be, and what are some of the dangers that could pollute the air, the natural occurrences, not just man-made occurrences, but natural events that would in some way destroy the purity of the air and actually endanger the organisms that live on the earth. So let's look at some of the dangers. As we start talking about the air resources, we have to talk about two cycles, and there are gases in the atmosphere that will cycle through solids and then go back into the atmosphere. So the first one that's very important is the cycle that cycles carbon dioxide, called carbon cycle. And carbon in the atmosphere is usually in the form of carbon dioxide gas, CO2. Carbon dioxide gas is expelled by humans and animals that when they breathe out. So it is a waste gas that goes out into the atmosphere. It's also important because it acts as a greenhouse gas as well. So greenhouse gas, along with water, will warm the atmosphere. So it almost acts like a blanket, making the atmosphere rather thick. So for instance, sunlight that can go through it as it's going down, because it's lots of energy, as it warms the earth and then bounces off the ground, can actually get trapped in this layer of a thick air, if you want to think of it as carbon dioxide and water. So it can add to the warming of the environment. So carbon dioxide is it's totally natural, but it's problematic in terms of what it can do on the large scale. So the carbon cycle, you can take this carbon out of the atmosphere, and the main way that's done is through plants. Plants, if you want to think of it, it breathes carbon dioxide, just the way animals and humans breathe oxygen. So as it comes into the plant, carbon dioxide from the air and water from the leaves are turned into sugar in the plant. And then that sugar is stored, and it's used to help the plant grow. It's used for the metabolism of that plant, and then is eaten by other organisms. So grass is eaten by animals, and apples are eaten by people. And that carbon that is now in the form of sugar once was carbon dioxide in the air. Now that carbon is then put into the animal's body, in the molecules that make up that animal, or the person's body is the molecules that make up that person. When that person or animal dies, or anything that decomposes, or anything from that animal that decomposes, then that carbon then goes back into the ground usually, and is broken down by the microorganisms, and eventually can be stored in the ground. So almost like a carbon sink, so that as long as it's not in the atmosphere, it's not problematic in terms of thickening the air and making it warmer. Then it's essentially trapping it. So that decomposed material can go back up into the atmosphere. The microorganisms would release it, or if any of the fossil fuels are burned, that trapped that carbon. So it's a big cycle, if you want to think about it, except that if you're burning fossil fuels faster than you are absorbing carbon dioxide from the atmosphere, then you have an increase in carbon dioxide levels. The other main cycle is the nitrogen cycle. Now, as a gas, nitrogen is inert, so it doesn't really do anything. It's about 78% of the atmosphere. But in terms of in the ground, nitrates, which is an oxygen compound of nitrogen, so NO3, is totally necessary for plants to grow. So you can think of it as plant food. It's also part of an amino acids chain, so any proteins that's going to be made need that nitrogen. So often a plant makes an amino acid simply by taking it from the soil in the form of nitrates. Well, in order to get nitrogen gas, so the plant doesn't do anything with nitrogen gas. nitrogen gas has no effect on that plant whatsoever, and it can't form nitrates as a result. There are a couple ways. You can have lightning. Lightning can break down nitrogen and then form it into nitrogen-oxygen compounds that then, when it rains, will fall into the ground. So that's one possibility. You can also have nitrogen-fixing bacteria, and nitrogen-fixing bacteria normally is in the roots of legumes, so clover and peanuts, peas and alfalfa, those type of things, beans. They have nodules on their roots that take nitrogen from the air and store it as nitrates. Then those nitrates are in the soil, are now able to help the plants grow. Okay, without it, it's essentially plant food. Without it, there's not really any way to do it. So nitrogen can be taken once it's in a body, in flesh of an animal or a person. It's usually in the form of proteins. Those proteins can be restored into nitrogen as it's breaking down. So if you have decay, so you have an animal hit by a car and it's on the side of the road and it's eventually decaying, those proteins will break back down into amino acids, break down usually by bacteria, and then restored to the atmosphere. So there's a cycle there. You can also have algae in the water, in the ponds, that can take nitrogen out of the air and put it into nitrates. Okay, so there is various paths of this cycle, and though that it really doesn't do much as a gas, it's totally necessary. If you think of no muscle tissue without nitrogen, no amino acids, no enzymes without nitrogen, but these nitrogen comes into the chemistry set via nitrates, which is an oxygen compound. So there are various ways that happens, and that's a cycle as well. Now, if you're talking about the air as a resource, keeping it clean is totally necessary if you're going to breathe it, or if it's going to be doing part of its job in terms of making chemicals naturally. You can pollute the air. So a pollutant is anything that poisons or makes that air not viable to a living thing. So if it somehow poisons the living thing rather than allows it to do what it's supposed to do, most of the air that's reacting positively is oxygen. So the oxygen in the air is reacting metabolically with plants and animals. A pollutant can, as it's breathed or taken in by a plant, can actually poison that living thing and kill it, perhaps. So there's various ways that pollutants come into the air. Naturally, it would happen by volcanoes. So volcanoes are not just letting out dust, which is a pollutant, but also lots and lots of acidic gases, so like sulfur dioxide gas and things coming out, because this is essentially deep within the ground, the reactants, leftover gaseous reactants of melted rocks. So things that would have been solid as rock form, if you melt those rocks into magma and then that erupts through lava, those gases will escape with the volcano, and that can go into the air and form all kinds of problems. We've talked previously about acid rain and acid precipitation. So if you were to have tons and tons of sulfur dioxide, which it could easily turn into sulfuric acid, and then that sulfur dioxide react with the water that's in the air and then become acidic, that acid could have detrimental effects to the plants and the animals that live on the earth. So it could bleach, if you want to think about it. It could allow the plants to not take up their nutrients well, basically kill those plants and animals. Another pollutant natural would be fires. So smoke has lots of gases and fine particulates that could then either be breathed by animals or people, and also have other gases that are, say, carbon dioxide is also be burning. By burning anything, that tree is storing carbon. If you were to turn it into carbon dioxide gas by burning it, that will increase the carbon level in the air as well. Another natural contaminant or poison is radon. Radon is a odorless gas that is on the periodic table. I think it's number like 86 or something like that. So it's one of the noble gases, and as such, it can percolate through the ground and up through the ground, and it's radioactive. And as radioactive, it could get into the tissues of an organism and actually change the DNA, and so monkey around with their blueprints, and that's always bad to do. So if you were to have this air that is got pollution in it, if it is concentrated, that concentrated pollution can be very detrimental. So say smog or some kind of localized pollution that people are breathing can cause health problems, diseases, all kinds of things. If it gets way, way high and then is kind of dispersed, say at the level of the troposphere, it's possible that less damage could be done because it's over a wider area, it's covering a wider area. It really just depends on how localized these pollutants are and which pollutants they are. Are they different types of atomized metals or acids or what? And what does it do to the body? So the type of pollutant, of course, is going to make the biggest difference. But keeping your wind as clean and your air as clean as possible is exactly what you would want to do if you want long-term success.